Hello everyone, my name is Stefan Hartmann, PA and exercise science specialist, bringing you all a new lecture today on sarcopenia, an undiagnosed epidemic. Let's just jump right into it. What is sarcopenia? You may have never heard of it before. There is an ICD-10 code for it, M62.84. Now why is this important? ICD-10 codes are international diagnostic codes that help epidemiologists figure out how prevalent a condition is. Unfortunately for sarcopenia, not a lot of medical practitioners are aware of this code, how to diagnose sarcopenia, and how important it is. So I'm hoping this lecture will help not only patients, but fellow medical practitioners identify this massive epidemic. So there's a bit of a definition for those interested in ICD-10 coding. Now, as for your medical provider who's maybe never heard of sarcopenia, how would they go about diagnosing this? Well, you can go on MD Calc, you can find the SARC-F score. And it's a simple scoring system, just a bit of strength, questioning, assistance with walking, rising from chair. Is this difficult? Not difficult. Pretty simple to understand. That is a pretty rudimentary analysis. You can also do advanced imaging such as DEXA scanning, and this can actually look at the percentage of body fat a person has to the percentage of their muscle mass. Other diagnostic imaging, which I'll point out later, include MRI and CT scanning, ultrasound as well. You can do muscle grading tests. So that's basically you test a patient in the office, see how strong their bicep is, and if it's like this, it doesn't budge, that's a 5 out of 5, they're strong. If it goes down a little bit, maybe that's a 4 minus if it's really weak. A 3, these patients are pretty weak. Now, sometimes this can be a neurological problem, a herniated disc causing a nerve impingement innervating the muscle groups. There's specific myotomes and dermatomes that can be tested. Now, someone with sarcopenia will have global weakness. It won't be isolated to a specific myotome and dermatome. So important to understand these nerve roots and where they innervate. So the pathophysiology of sarcopenia, let's kind of describe that right here. So as one ages, it's traditionally thought as you age, you lose muscle mass and it's replaced by fat. Now, I would consider this actually pathological aging. Pathologic aging is essentially sarcopenia. We see this all the time. Right, the elderly person, they have no muscle strength, they walking around, they fall, right? Falls in the elderly are a huge problem. And this is from a lot of different reasons. Sometimes they can have multiple medications, so polypharmacy is what we call this. It can cause them to have dizziness, vertigo. Maybe they have orthostatic hypotension where they go from a laying position to a standing position, and this causes a drop in their blood pressure and they fall. But sarcopenia, so muscle wasting, was also a contributing factor to falls and morbidity and mortality. So there's a couple theories as to how this happens here. It's kind of essentially a self-fulfilling prophecy. So you have in one spectrum the obese patient, they'll have more fat, and so they'll have more inflammation, and so this causes a bit of a destruction or wasting of the muscle. But also, you add on to this the excess high energy intake. This is causing obesity, but the energy that they're consuming is low nutrient density. So a lot of carbohydrate, a lot of wasteful energy. So this causes obesity, and the obesity actually makes the person more sedentary. And then when you're more sedentary, your muscle wastes. So you have less muscle and you grow more fat. And this process just perpetuates ad infinitum, right? There's no way to break this cycle unless proper effort is taken and it's identified as a huge problem, right? Another thing to think about is how caloric intake typically doesn't decrease over the lifespan. So you take perhaps an individual who's an athlete earlier in life, they're accustomed to eating a certain amount of energy per day, but then as they get on older in life, maybe the mid-30s, 40s, they're not soccer players anymore, but their stomach is accustomed to eating like a soccer player. So they're working a 9-to-5 job, they have kids at home, they're not getting that same exercise, they eat the same amount, so they grow a lot of fat, but they're not exercising daily, so their muscle isn't growing at all. Here's some images of an MRI scan. So invasion by fat cells in the MRI of it looks to be some sort of limb. Now, this is one modality that can be used. Typically, radiologists won't note invasion by fat cells on the MRI. It's not usually what they are looking for. You can actually perhaps ask a radiologist, hey, can you look at my MRI again and read the fat on my thigh? I think that'd be helpful for me. And probably you could pay the radiologist to do that. Let's talk about the concept that if I'm not a bodybuilder or I'm not an athlete, do I really need to be working out all the time? And the answer is yes, you do need to be working out. You do need to be stimulating a muscle. This is not just for bodybuilders, right? Bodybuilders typically will eat a lot of protein per day. They'll be working out twice a day. And some people will think, well, why would I need to do this? My goals aren't to compete in the Olympics. Well, we don't need to be all competing in the Olympics, but we still have to stimulate our muscle structures. Now, why do we need to do this? Look at the several recent adverse outcomes of sarcopenia identified. So increased risk of falls leading to fractures, disability, and functional impairment. Dysphagia, which is trouble swallowing. Lower quality of life and all-cause mortality. Risk of infection after surgery increases in these sarcopenic patients. And then sarcopenia also predicts the risk of community-acquired pneumonia in the elderly, as well as 90-day mortality in patients suffering from aspiration pneumonia. And this may go along with dysphagia. Aspiration pneumonia is where when you're consuming food, you inhale it down the wrong pipe, maybe because you have trouble swallowing, you're weak. Who knows why it happens, but it happens all the time in the elderly. Elderly die all the time of aspiration pneumonia. It's a huge cause of morbidity and mortality. So, another key thing to note is that elderly are likely not consuming a properly animal source food diet. They're probably eating low nutrient density. So maybe I've counted it all the time. An elderly person will tell me, well, I eat a little bit of toast in the morning and then maybe I'll have an avocado for lunch. There's essentially no significant animal protein in their diet. It's all based out of carbohydrate and fats. And so you're not going to get the amino acids you need to have muscle synthesis. And thus, sarcopenia takes place. And we see it all the time in the elderly. So, what's the significance of sarcopenia? As we said, low skeletal mass is associated with risk of all-cause mortality in patients with type 2 diabetes mellitus. And it is a predictor of mortality among critically ill in an intensive care unit. So further points as to why we want to really fight sarcopenia and identify it. Okay, sarcopenic obesity, known as skinny fat. So skinny fat phenotype. So muscle mass in the elderly is associated with increased fat mass. Yeah, and there's going to be an imbalance between skeletal muscle mass and visceral fat in older adults. So visceral fat, we just talked about that before. That's fat on the organs. Now, sarcopenia is fat infiltrating and replacing muscle. So two different independent risk factors for all-cause mortality. So can you still have sarcopenia if your BMI is high? The answer is yes. And that's just because of BMI being a poor indicator of overall health. Now, for myself, I'm 5'10" at 175 pounds. If you look at the BMI chart, it says that I'm overweight. And this is not the case. I just have a very high preponderance of muscle. I have a very low fat. So, and muscle weighs more than fat. It takes up less volume. So it kind of sets off the BMI chart wrong. Unfortunately, BMI is the standard of measurement. So when you go to an office, you're going to be checked your height and your weight, and you're going to get a BMI. Maybe you're in the obese section. Maybe you're in the underweight section. This is a poor way of measuring people, and it misses sarcopenia. You can have someone who's overweight but has a very low muscle mass, and they're completely misdiagnosed. And as we can see, this misdiagnosis can potentially be deadly. We can see how important sarcopenia is with risk factors for things from aspiration pneumonia to survival rates in critical care units. So how do we reverse sarcopenia? Well, we have to focus on nutrient density. We have to be making sure we're getting the right ratios of minerals, vitamins, and amino acids. And how are you going to get this? An animal source diet. So eating nose to tail, eating the liver, eating the meat, making sure your diet has a proper ratio of nutrient density to fun foods. And I would consider fun foods everything from alcohol to breads, rice, potatoes, and some veggies. A lot of these so-called healthy foods are nutrient deficient just because of the soil that they're raised in the US. Most of the soil is nutrient depleted, and these plants would not grow if not for Monsanto and genetically modified seeds that specifically grow in poisonous fumes from pesticides. So you get a nutrient depleted source of food that's essentially empty calories, and you think you're eating well because the food is colorful. It's potentially not true unless you're getting very fancy organically raised vegetables, and even these are not going to have the same mineral profile as, say, liver, and especially will not give you the amino acids as, say, steak and liver would. And we can look at some of the current hunter-gatherers. These hunter-gatherers that currently live in the Hadza in Africa are one that come to mind. And these people live off an animal source diet. Very minimal consumption of veggies, pretty much none, maybe some roots that they kind of suck the juices out of these roots and kind of spit out the fiber. So what you can think about doing is limiting the amount of fun carbohydrates and alcohol. These are going to be empty calories that are not going to be providing any value for you. You have to start a progressive resistance training program that will help build your muscle. You can work with a personal trainer to start that. And you have to think about how much exercise you're getting per day versus how much energy you're consuming. So if you're going to the gym 1 hour per day and then the rest of the time you're sitting, that's essentially not what we evolved to do, right? You can think of how these current hunter-gatherers live. They're walking, they're exercising 8 hours a day, trying to hunt for their food. So we evolved to work a lot harder than we currently are. So really take that into consideration, is how much food you're putting in, what is the quality of the food, and how much exercise you're getting in. And that's going to help determine if you're at risk for sarcopenia and whether you are on that trend towards sarcopenia or whether you're taking the proper steps to reverse it and prevent it from happening in the first place. One question I get is, can a vegan diet reverse sarcopenia? And this is Dr. Michael Greger. He's of nutritionfacts.org. He is a vegan physician who promotes vegan diet for a whole variety of health maladies. So we look at this study here that looked at this significant decrease in muscle mass index and lean body mass in vegan compared to vegetarian and omnivore groups, and higher serum homocysteine, which is an inflammatory marker, in vegetarians and vegans compared to omnivores. So the results obtained in the study demonstrated that restrictive vegan diets could not prevent the onset of metabolic and cardiovascular disease, nor protect by oxidative damage. So these vegan diets, or you consider them fad diets, a lot of people will see temporarily improvements in their health just by the fact that they're eliminating all processed foods in these restrictive vegan diets. But over time, you're not going to get the right amino acids, you're not going to get the right minerals, vitamins, and your muscle is likely going to waste unless you're taking a lot of supplements, unless you're really focusing on that. It's a lot easier just to focus on animal source foods. You're going to get the whole product there, and you're not going to have to, tinker with supplements so much. Essentially, animal source foods requires no supplements. You're going to get all the supplements you need from eating nose to tail. So veganism is more for a luxury, right? It's someone who can live in a first world country and have access to a lot of supplements, and someone who can monitor their blood work so they're not getting mineral deficient, so forth. So it's really a kind of a high income sort of a first world way to eat, and it's not appropriate for most people around the planet. Let's see. So, but eating lots of protein to build muscles for bodybuilders, yes, we're going to cover this one more time. So we can look at here of the pathophysiology of sarcopenia as it relates to aging muscle and how this really contributes to a poor endocrine function. So muscle is an endocrine organ, just like your thyroid is, just like your pancreas is. And that may seem novel to you, and it is relatively novel, and scientists are figuring out how important muscle is for your hormone functioning. So we can see a lot of these inflammatory molecules, these IGF-1s, these myokines, cytokines. These might sound familiar because of the recent pandemic. And we've seen how these inflammatory molecules actually cause the disease of COVID. It's not necessarily the virus itself, it's the body's response to the virus. And it causes this huge cytokine storm and kills people. Now we can see the pathology in someone with an aging sarcopenic muscle. Is their response to such illnesses such as COVID is likely going to be altered. So these patients with sarcopenia potentially or theoretically could be more at risk for adverse outcomes in COVID disease. Alright, let's move on. But isn't eating lots of animal protein bad for your kidneys? In the short, only in chronic kidney disease in patients previously diagnosed with chronic kidney disease, so impaired renal function. Yes, a high animal protein diet could potentially be harmful to the kidneys. But in someone with healthy functioning kidneys, we can see in interventional trials that very high protein consumption per day, we're talking up to 3.3 grams per kilogram of body weight per day over a 4-month period, had no effect on renal and hepatic function in the healthy populations. We have to go over a Korean prospective study because they noted a decrease in GFR in their high protein group. But when I looked at their high protein group, we can see that this high protein group was more likely to be a smoker, was more likely to drink more alcohol, was more likely to be male, more likely to have diabetes, more likely to have high blood pressure, though there's a lot of other reasons here for why someone would have a decrease in kidney function and not just more animal protein. And I guarantee you, this study didn't differentiate if a person was eating liver and meats or whether they were eating a Burger King, fries, and all the other things that go along with an animal-based diet. We have to bust the myth. Metabolism slows down as you age. So this is false, and I hear this all the time. Someone will tell me, my metabolism is getting slower. I wish I had your metabolism. Well, my metabolism is very high because I work out all the time. I eat a higher protein diet, so that in its alone is going to increase my metabolism. This is well known that a carbohydrate such as bread does not require the same energy to digest as, say, liver or a steak. You're going to burn more energy digesting these nutrient-dense animal protein compared to if you say you ate a French fry. So that's one part of why the metabolism myth is not true. The second part is as you get older, you're more likely to be more sedentary. So yes, your metabolism is going to slow down. But if an aging person remains active, is training hard, there's no reason for a metabolism to slow down at the rates that it currently accepted as normal. I would consider it pathological slow metabolism with age, not normal metabolism with age. There's no such thing as normal metabolism slowing down with age. You can fight it off by following the proper steps. And we can see this here in studies. Increase in muscle mass is accompanied by increased resting metabolic rate. In as little as 12 weeks, resistance training for 2 or 3 days a week can lead to muscle hypertrophy. In similar muscle fiber sizes in young and old, untrained adults. So in frail adults older than age 85 years old, 3 months of resistance training selectively increased type 2 muscle fibers, which are preferentially lost with aging. So really this study shows us that there's no wrong time to start a progressive resistance training program. So sarcopenia in summary, we have an ICD-10 code, we need to start using it, identifying just how prevalent this is in the population, because I suspect it is massively underdiagnosed and we have an epidemic of sarcopenia throughout the planet, especially in the US. Age-related muscle mass is a strong age-related muscle loss is a strong risk factor for disability, hospitalization, and death in older adults. Metabolism does not slow down as you age. The individual slows down, and thus metabolism slows down. Thus, muscle becomes sarcopenic, and this causes metabolism to slow down as well. If appetite remains the same as one ages, then sarcopenic obesity results. Resistance training reverses sarcopenia even adults older than 80 in as little as 3 months. Increased animal source foods and even supplementing with BCAAs can reverse sarcopenia. And sarcopenia is not just an aesthetic concern. Muscle is an endocrine organ. So we can see that patients are going to have improved inflammatory response to injury and infections with better muscle. And eating large amounts of protein, even above 3 grams per kilogram of body weight per day, is shown to be healthy and safe in healthy individuals on progressive resistance training programs. High protein diets in interventional trials on comorbid and general populations have been shown to improve body composition, reverse sarcopenia, and reverse diabetes. There are epidemiological studies that show a decrease in GFR, but these studies are limited to observations by their nature, and there are other confounding factors such as diabetes, smoking, and alcohol that would better explain the decrease in GFR observed. And I would always recommend monitoring your renal function with your primary when on such a diet, just to, be safe. Hope you all enjoyed this lecture. I'll see you all next week.